Using trigonometry to solve practical problems. Compass directions. The diagram below shows the four main compass directions: north, south, east and west. So north, south, east and west. For all other compass directions, we can begin by looking north or south and then turning either east or west through the required number of degrees. This is shown in the diagrams below. One could also begin by looking east or west and then turning north or south through the required angle. So this angle here is north, theta degrees east. So north, theta degrees east. So for example, it could be north 30 degrees east. This angle here is north theta degrees west. So it could be, for example, north 60 degrees west. This angle here is south theta degrees west, and this angle here is south theta degrees east. Angles of elevation and depression. If you look up at a tall building or object, the angle that your line of vision makes with the horizontal is called the angle of elevation. So for example, here we have the horizontal line, which in this example is the ground. We have an observer, and their eye line or sight line is the angle of elevation. So they're looking up at the object in the sky, and the angle that is made with their sight line to the ground, this is known as the angle of elevation. So the angle of elevation is the angle above the horizontal. If you stand on top of a cliff and observe a swimmer out to sea, the angle that your line of vision makes with the horizontal is called the angle of depression. Or in this example, we have a man standing with his camera, and the horizontal line this time actually starts at his eye line, not at the ground. And we measure the angle downwards. So we can see that this is the horizontal, and this is the other arm or ray of our angle, and this is the angle of depression between. So the angle of depression is the angle below the horizontal. So angle of elevation is the angle above the horizontal line. So here's a horizontal, and the angle of elevation is above it. And the angle of depression is the angle below the horizontal. So here's the horizontal line, and the angle is below it. A ship leaves a port A and sails a distance of 4 kilometers. So here is port A, and here's the distance of 4 kilometers. In the direction of north 30 degrees east. So this is our north line, and from the north line we move 30 degrees to the east, and that is the angle at which the ship travels, and it moves a distance of 4 kilometers. So a ship leaves a port A and sails a distance of 4 kilometers in the direction of north 30 degrees east. The ship then changes direction and sails a further 6 kilometers in the direction south 60 degrees east to a point C. So the ship starts at point A, it travels 4 kilometers to point B, then changes direction and travels 6 kilometers to point C. Part 1. Calculate the distance from the ship's present position at point C to port A. So find the distance from C to A. Give your answer to 1 decimal place. Part 2. Find the angle BCA to the nearest degree. So the angle BCA, so this angle in here. So for the moment I'll label that angle X. And part 3, hence, find the direction of C from A. Okay, so part 1, calculate the distance from the ship's present position at point C to port A. Give your answer to 1 decimal place. So this angle in here must be 30 degrees because we have our north line with a straight line down, and then we can also draw a north line straight down through point B, and we're actually forming parallel lines. So here's our north line, and here's another north line, and they're parallel. And the line AB is technically a transversal cutting through the parallel lines, and we know that alternate angles are equal, so if this is 30 degrees, then this angle must also be 30 degrees. So this is 30 degrees in here, this angle. And 30 degrees plus 60 degrees equals 90 degrees. So we actually have a right angle, which means that the triangle ABC is a right angle triangle. And we are trying to find the distance from the ship's present position at point C, which is here, to port A. So we're trying to find this distance. So we can label this as X. So we have this length here, AB, to be 4. And we have this length, BC, to be 6. And we're trying to find X. And since we have a right angle triangle and we have 2 sides and we're trying to find a third, we can use Pythagoras' theorem. And Pythagoras' theorem states that c squared equals a squared plus b squared. So we need to label our triangle. We're going to label our X as C, because C is always the longest side. C is always our hypotenuse. And then it doesn't matter which way we label the 4 and the 6, but I'm going to label the 4 as A and the 6 as B. So substituting into my formula, I have c squared, which is going to be x squared, or in this case ac squared, equals a squared, which is 4, so 4 squared, plus b squared, which is 6, so plus 6 squared. 4 squared is 16, 6 squared is 36, and 16 plus 36 is 52. So we end up with ac squared equals 52, or you could say x squared equals 52. So to find AC, we're going to have to square root 52, and the square root of 52 is 7.2 kilometers rounded to 1 decimal place. So the distance from A to C is 7.2 kilometers. Part 2, find the angle BCA to the nearest degrees. So BCA, so we're trying to find this angle here. I'm going to label it as X. Now remember, we found this angle in here to be 30 degrees, and this is 60, and 30 plus 60 is 90, so this is a right angle. So since we have a right angle triangle, and we're trying to find an angle, and we know 2 of the sides, we actually know a third side as well, we can use SOHCAHTOA to figure out what the angle is. So what we're going to do is label our triangle. So first of all, the hypotenuse is the longest side, and it's always looking across at the right angle, so I'm going to label this as H. This is the angle that we're looking for, and it's opposite this side here. So 4 is going to be labelled as O, the opposite. And then the leftover side is going to be labelled as A, adjacent. Now, since I have O and I have A, I'm going to go with TOA. So TOA stands for tan equals opposite over adjacent. So it's going to be tan of X, or tan of theta, equals opposite, which is 4, divided by the adjacent, which is 6. So get tan of theta, or you could say tan of X, equals 4 over 6, which is 2 over 3. Now the rule is, when we do not know what the angle is, we have to use the inverse function. So we have to press Shift and tan, and tan minus 1 will come up. So this is known as the inverse. So to get the inverse on the calculator, you either press the shift button or the second function button, depending on which calculator you have. And a bracket will open up. You're going to press the fraction button, and you can either put in 4 over 6 or 2 over 3, it doesn't matter which. Close your bracket and press equals. So we get theta equals 33.69 degrees, and round it off to the nearest degree, which is what we were asked to do, we get 34 degrees. So the angle BCA is equal to 34 degrees. So this angle here is equal to 34 degrees. Part 3, hence, find the direction of C from A. So hence means using what you have already found. Now we have to be very, very careful with the phrasing of this question. The direction of C from A. So from A means we have to go to point A, which is here. This is point A. And we need to get the angle that it makes with point C, with the line connecting to point C, from the horizontal. So this is the horizontal, this is point A, this is point C, so we need to get this angle in between. So find the direction of C from A. We go to point A, and it's the angle that this horizontal line makes with the line that is connected to C. So this is the angle that we're trying to figure out. So a cross had already been drawn in at point B, so north, south, east, west cross, or you could call it a compass. So it would be helpful to draw one at point C as well. So north, south, east, west. And what this forms is right angles. So since we already knew that this angle was 60 degrees, then the angle that is formed here is going to be 30 degrees, because this has to be a right angle, and 90 degrees, take away 60 degrees, is 30 degrees. So the angle FBC, so FBC, this angle here must be 30 degrees, because this must be 90 degrees. Now if we were to extend this line and extend this line, we would form two parallel lines, which can be seen here. And the line BC now becomes a transversal. So if this angle here is 30 degrees, then this angle here must also be 30 degrees, because alternate angles are equal. So angle BCD, so BCD must be 30 degrees, because it's alternate to angle FBC, which is up here. Now in part 2 of the question, we found this angle to be 34 degrees. So if this is 34 degrees and this is 30 degrees, then 34 degrees take away 30 degrees is equal to 4 degrees. So this angle here is going to be 4 degrees. Now this line that I drew in is also parallel to the east line. So the line that goes from A through point E and continues on. So this is the east line. So these two lines are also parallel. And if this angle is 4 degrees, then this angle must also be 4 degrees. Because again, alternate angles are equal. So angle CAE, so angle CAE, so this angle in here, which we're looking for, is 4 degrees because it's alternate to angle DCA. Hence, the direction of C from A is east 4 degrees north.